Now let us do some problem sets on lesson 3-5. So again, we have quick problems. Question number 1, find r square if s's res is equal to 2 and s's def is equal to 10. Okay, it's quite easy. So what is r square? R square is the coefficient of determination. So this is defined as the difference between the sum of the squares of the deviation minus the sum of the squares of the residuals over sum of the squares of the deviation. So r square is equal to 10 minus 2 over 10, and this is 8 over 10. In decimal, this is 0.8. Okay? Next, this is the question number 1. Now we go to question number 2. Find the correlation coefficient if the coefficient of determination is 0.9. So how do we solve for this type of problems? R square is 0.9. And the coefficient of the correlation, or the correlation coefficient, is just the square root of r square. And that pretty much gives 0.9. The square root of 0.9 is equal to, what is that? Square root of 0.9. That's actually 0.9486. Okay? Okay. Now we go to question number 3. Find y hat for the point 39 if y hat is equal to 2x plus 7. Okay. So the y hat here, or the residual, okay, would then be, so y hat of 3 for x is equal to 3. So we will have 2 times 3 plus 7. So that's 6 plus 7 is 13. Okay? And the residual is, what is the rest here? From that point to here, that would be, what is the point? Okay, that would be 4, positive 4 unit. Okay? From that point to y hat. Okay? Okay, so Q, question number 4. Find the residual for the point 39 if y hat, oh, okay, so that's it. So the point is 39, and our y hat is, we have 3, the point is 39, okay? And our residual is actually 3 and 13. So the residual is that one, okay? It's positive 4, right? Okay, find the deviation for the point 3, 9 if x, or the mean, is 5 and y is equal to 6. So to find it, just subtract, just get the point is above your mean. So if the mean is 5, 6, okay, and the point is 3, 9, so the deviation here is just y minus y mean. So this is equal to, okay, I think I have to, we have something here. So you can see that the residual, is y minus y hat. And y minus y hat here is 9 minus 13, so that's negative 4. Okay, so the rest is negative 4. On the other hand, y minus y hat here is equal to negative 3. Alright? No, no, no. Okay. We have y. Our y is 9. Our y, the mean is 6. So that would be 3. Positive 3. Okay? Okay. Question number 5. Find a deviation. Oh, I think we're finished with that. We get to question number 6. Question 6, find the y-intercept if y hat is equal to 2x plus 7. So the y-intercept happens when your x is equal to 0. So y hat, the y-intercept is equal to 7. Okay? Question number 7. Question 7, find the coordinate or the x-coordinate of the vertex of this parabola. Y is equal to 3x squared plus 24x plus 71. Okay, so we have a formula for the vertex, and that is negative b over 2a and f of negative b over 2a. Am I correct? So, looking at the x coordinate, this is the x coordinate. So, this is our a. This is just a review. So, it doesn't necessarily mean that it involved our what I call the this current lesson about residual plots. It's just a review of the previous lessons. Okay, so this is our b. So the x coordinate is negative b over 2a. So negative 24 over 2 times 3. So that's negative 24 over 6. So the x coordinate is negative 4, right? That's the answer. Okay. Problem set number 1. Radio sound air pressure problem. Meteorologists release weather balloons called radiosondes each day to measure data about the atmosphere at various altitudes. Okay, so this figure, it does 4F, and the table show altitude in meters, pressure in millibars, and temperature in degrees Celsius measured in December 1991 by a radiosonde in Coffeyville, Kansas. So this is a radiosonde. Okay, this is being used by the meteorologist in order to acquire some data about the atmosphere at various altitudes. So this is the data. Okay, this is actually a graph, and this is figure 8-4F. Okay, so this is figure 8-4F. And this is the table. Okay, this is the table of the height, pressure, and temperature. So these are the data being taken or being measured for the specific radiosonde. Okay, so height of 400. What is the height in? The height is in It doesn't say here, so it's in meters. Okay, the height is in meters, and pressure is in millibars. So let us clarify height in meters and pressure millibars. Okay, okay, and temperature is in degrees Celsius. So this is meter, millibar, and this is in degrees Celsius. Okay, explain why an exponential function would be expected to fit the data well. By regression, find the best fitting exponential function, record the correlation coefficient, and paste the equation into your graph first, y equals menu. Plot the equation on the same screen as the scatter plot. So we're going to uh, plot the height versus pressure graph on the grapher, as well as find the regression function for this data, scattered data. Okay, so if we are going to use the scattered plot, okay, you could see that the grapher will automatically give you similar background or similar pattern as this one. So it is concave upward, but is decreasing. And as it goes here, notice that it won't touch your height equals 0. Okay, so therefore the exponential function is the more effective or the best fitting regression for this type of data. Am I correct? Okay. And the points seem to lie very near the graph on the right, somewhat less near on the left, and in the middle. Okay? So as you can see the graph, if we are going to uh, run a regression for this data, we could see that the regression would somehow do like this. Okay, so you can see that the points lie very near the graph on the right. So you can see the graphs are here. Okay, the points are here. They lie very near on the left, I mean on the right, and somewhat less near on the left. So you can see the points are less here. And in the middle also. So you could see the points here just barely touch the points. But on the right, you can see that the points lie strictly on the curve. Okay? The scatter graph will give us the regression equation, which is y hat equals 1076.9102. Okay, let me fix my 2 times. Let me use a bracket, okay, or a parenthesis instead. 0.98 or 0.9998 raised to x with the coefficient of correlation as negative 0.9985. And why is it negative again? Because you could see that the data, especially the pressure in millibars, are decreasing. Now let us take a look at the pressure. They are decreasing as height increases. So you could see that it is your R, or coefficient of correlation, is negative. Okay? And also notice that your temperature in degrees Celsius okay, decreases up to a height of 18,195 meters, your temperature goes to negative 70.7 degrees Celsius. Okay, and the pressure there is at that height at 18,195 becomes 75 millibars, very low. Okay, so let me sketch a graph of the the scatter plot. So, but using your grapher, you should be able to get more accurate plotting. Okay, so this is my scatter plot. This is 400. This is 800. Okay, and this is 10,000. And so if I run a scatter plot, it will give me something like this. Okay, so the best fit is, or the best fitting regression function is the exponential function. If I'm going to use the scatter plot, you could see that the points are scattered and they are less near on the left, and in the middle they're like this. But as they descend, you can see that the points lie on the lines. Okay, the points lie on the lines. Okay, so this is the scatter plot of the function, the regression, running the regression for exponential function for our grapher. This would be the scatter plot. Okay, so that's it for today. We're going to continue some problem sets tomorrow for chapter 5, and then after that we will proceed to the chapter test review and electronic test, and then go to the next chapter. So thank you for watching and have a nice day.